Alright guys, so I just wanted to spend a little bit of time just going over the review, and I hope that you guys are working with me. If not checking your work, I'm going to go into a little bit more detail to help you guys out. So let's jump right in. First, make sure that your name is on it. This is going to be due on Monday, and then we'll go from there. So first, on the test, you guys will definitely be asked to find area and circumference of a circle. So finding the area and circumference of a circle. If they don't tell you to approximate or exact, just go ahead and do both. Okay, so area is equal to pi r squared, and then circumference is equal to 2 pi r, or pi times diameter. Thank you, Miss Maslin. No worries. And then the area is going to be equal to pi r squared. So the first thing is, let's talk about the radius. The radius is the center of the circle going all the way out to the edge of that circle. So when you have a line straight through like this, or a line that measures approximately all the way through on the outside, and let's say that that's 14, that's really called the diameter. So if this is 7, this is 7. 7 plus 7 is 14. So the diameter is the length of all the way through the circle. So I know that my radius is 7. Here we're going to go area is equal to pi 7 squared. Okay? Area is going to be equal to pi times 49, not 14. Some of us are still thinking that 7 to the power of 2 is 14. Remember, just if you're going to be worried about that, just do 7 times 7. You're multiplying that number twice. So area is equal to 49 pi. And that's my exact answer right there, centimeters squared. When I actually just stop after I square the radius. And then to go to approximation, I would go 49 times 3.14. And the area is approximately 153.86 centimeters squared. And there's my approximation, and there is my exact. Circumference is going to be the same thing, except we're not squaring, we're just multiplying the radius by 2. So circumference is equal to 2 pi times 7. Circumference is equal to 14 pi. And there is my exact answer. I'm not going to square it, so I just leave it to centimeters unit alone. So it's just centimeters to the first power. And then to get to approximation, I just go centimeters is approximately 14 times 3.14. Circumference is approximately 43.96 centimeters. Okay, so
Clarice Ianu to the office, please. Clarice Ianu to the office.
So that is an example of how you would find exact and approximation for area and circumference of a circle. Okay, let's go to the next question. The next question is, what is the circumference of the circle? Use 3.14 as approximation of pi. So circumference is 2 pi r. Twinkle, twinkle, little star. Circumference is equal to 2 pi r. But I gave you area is equal to 16 pi. Well, I'm just going to go ahead and write down the area formula. Pi r squared. Notice how this has a pi symbol in the formula and then a pi symbol in the answer. Area is equal to 16 pi. That's the exact answer. So this must be in place of r to the second power. So that really means that r to the second power is equal to 16. In other words, what two identical numbers equals 16? Multiplying together makes 16. In math, the inverse of squaring would be square rooting. R is 4. R is 4. So now that I have the radius, I can check my work if I want. Area is equal to pi r squared. Area is equal to pi times 4 squared. Area is equal to 4 times 4 is going to be 16 pi. So now that I have the radius, we can just simply substitute that into the circumference formula. Circumference is equal to 2 pi 4. 4 times 2. Circumference is equal to 8 pi, which is circumference is approximately 8 times 3.14. Circumference is equal to 25.12 units. Okay, so I gave you exact form in area. You had to find out the radius in order to carry out the circumference formula. Okay. The last one on the first page. The surface area of a cube is 216 inches squared. What is the volume of the cube? So let's talk about a cube. The cube's it's gonna have 6 equal squares. Okay, so I'm just going to draw the cube, and then I'm going to draw out the 6 perfect squares. I'm not going to draw it perfect. Okay, there are my 6 squares. I also know that if I add up all of these surfaces, it equals 216 as the area. So there must be the same area in each of these 6 faces that I add up to equal 216. So to undo that, instead of adding 6 or adding the same number 6 times, we just take the area, multiply by 6. So to undo that, I would take 216 divided by 6 and find out that that's 36. That means each of these squares are 36. These are my 6 faces. Here's my top, bottom, left, right, front, and back. I add them all up, they'll equal 216. But I also know a square has equal sides. And how do you find the area of a square? You would take one side and you multiply by the other, side times side. In other words, side squared. If you do length times width, you'll be length times width is equal to 36, understanding that they're the same sides, the same length. So here we go. Side squared is equal to 36, one of these squares. Square root. One side is 6. So these are all 6's around the square. Now that I have that side, we can find the volume. Volume is equal to area of the base times the height. Well, if it's a square, and these are all 6's, 6, 6, and the height 6, so the volume is equal to area of the base. Area of a square is going to be 6 times 6 times the height, which is 6. Volume is equal to 36 times 6. The volume is also equal to 216 inches cubed. This is one of those rare instances where you have a cube that has the same surface area and the same volume. Okay. Now if I'm going too fast, pause the video and just keep working it and then play it to check your work. You can always go back. Okay, let's go to the back side. 2 left. Find the area of the following. Now, I saw that some of you wanted to do a triangle right there. I wouldn't recommend that because this length right here, that's pretty difficult to find. But instead, so far in this unit, we've looked at squares and circles, parallelograms, and yes, triangles. But the easiest one to find so far is squares, the area of squares. And what I want you to do is see this whole length right here. We talked about it on the front page. The distance across this circle is 10. So the radius is 5. Here's my radius. Which means I can go all the way in and all the way up, and I can actually see this square right there. I'm going to pull this square out. This square is actually 5 by 5. Well, fair enough. The area of that would be side squared, which is 5 squared, 25. So this area right here is 25. But if I keep drawing 2 diameters straight across like that, we'll make it a little pie chart. I also see 1, 2, 3, and somewhere in this 25 is my actual circle. So how many parts of the circle are left? I actually see 3/4 of the circle left. 1, 2, 3. So in order to find 3/4 of a circle, I need to find the area of just a circle first. Area is equal to fuzzy wuzzy as a bear area equals pi r squared. I already determined that the radius is 5. So area is equal to pi times 5 to the 2nd power. Area is equal to 25 pi. I'm going to go ahead and change that into approximation. 25 times 3.14 and that's going to be area is approximately 78.5. So this entire circle is 78.5. That's not the solution yet, because now I got to figure out how much of the circles that is not accounted for besides this square. So since there are 4 equal parts in the circle, I'm going to go ahead and divide 78.5 by 4 to get approximately 19 point, let me double check my work here, 63. I'm going to go ahead and round to the nearest tenth. So this piece is 19.63, this piece is 19.63, this piece is 19.63. And somewhere in this 25 is actually the 19.63. If you really want to figure it out, you can go 25 minus 19.63, and really in here is 19.63 and then 5.37 left of the point that probably this piece that's poking out right there. So to find the total area of this figure, I just add that number, that number, that number, and those 4 numbers together. So it's going to be 19.63 plus 19.63 plus 19.63 plus 25. Those are all of the shape. Here's 1 part, 2 part, 3 part, 4 parts. Because I split this shape into 4s. 3 parts of a circle, 3/4 of a circle, and then a square. So 19.63, add that 3 times, equals 58.89 plus 25. So all of this together, the area of the total shape is approximately 83.89. Okay. So when you're seeing shapes like this, pull out easy shapes like squares, and then find the area of a circle given the radius, and then you'll have to do some dividing. You guys have seen like half circles and semicircles, which they're called semicircles, in the math space. It's the same thing here. Okay, last question. Finding the surface area of the following. Okay, I'm going to go ahead and section these off so that I can list them out to the left. I have face 1, face 2, 3, 4, 5. I'm going to go ahead and break that up. 6. I know that there is an 8th back here. I also know that this 6, there's a matching side on the parallel sign. That would be 9. Same thing over here with this step. That would be 10. And then there's that bottom piece, 11. So I need to find 11 total surfaces to add them together. Yes, you can technically say that 5 and 6 are just one surface, but because of the odd composite shape, I'm going to split it into 2 manageable rectangles. Okay, so before I actually go in there and start finding all the areas of all the rectangles, I'm actually, because I broke this off, I need to know this height. Because this height right here and right here, the one I'm sketching on, is the same. I also know that this is 19. I also know that this is 6, therefore this is 6. So I can quickly do some math. 19 minus 6, then this has to be 13. Because all of this is 19 units. Alright, so let's just do face 1. Face 1 is going to be this top part right here. That is 14 by 48. So 14 times 48. So if this is 48, this must be 48, this must be 48 as well. It's 48 wide. Okay. Face 2 is going to be 6 by 48. Face 3 is going to be 19 by 48. Face 4, that is going to be 13 by 48. Face 5, that's the one that I just broke off. Okay, that's going to be 13. And this whole thing right here is 33. So if I'm going to break this off, from here to here is 14 because it's parallel with this one. It matches this one. So in my calculator, or I can just do 33 minus 14 just to double check. That's going to be, this is 19. So that's 13 by 19. Okay. And then to find this face, face 6, I just broke that up, 33. Okay, so if this is 14, this is 14, I just split that up over there. This must be 14 as well. So that's a 14 by 14. So I actually just found the area of face, this irregular shape right here. Face 7 is going to be, did I miscount it, guys? So 1, 2, 3, 4, 5, 6. Sorry, this should be 7. Face 7 is that back side. So that's a 48 by 19. So it's 48 by 19. And then I'm going to work my way around. Instead of 9, it's going to be 8. Okay, face 8 again is going to be a 14 by 19. Because I'm finding this face. Face 10 is going to be this shape right there. And I already found it. Face 10 and face 5 match up. So face 5 is the same as face 10. 13 by 19. Sorry, that should have been face 9. Fix that. And then the last face, the bottom one. The bottom one is going to be 33. 33 long. And it's going to be this wide. And that is 48. Oof, that's a lot of faces. But this is a composite staircase, right? So we're going to have to find each surface, and then we're going to add it up. So I'm going to jump right in. 14 times 48. Okay, that's going to be 672. Before I move on, I'm going to scan my list. Any more 14 times 48? Okay. Nope. Next, 6 times 48. That's going to be 288. 19 times 48. It's going to be 912. I saw one of those earlier. Right there. 13 times 48. That's 624. Okay. Then I get 13 times 19. 247. 14 squared is 296. Excuse me, 196. 14 times 14 is 196. 14 times 19 is 266. 13 times 19. 247, and 33 times 48. It's going to be 1,584. Okay. Now I'm just going to add all of these numbers up. So 1584 plus 247 plus 266 plus 912 plus 196 plus 247, 624. And the final solution is the surface area of this composite shape is 5,948. There's no units, so just units squared. Okay. For shapes like this, there's really no easy way to do this, guys. We're going to have to break it up and find each individual faces. In this case, I found 10 faces. Okay. So I hope that helped, and please double check your work, and we'll go over in class. Thanks, guys.